Thanks for watching. I'm working more on my stock market model today. And let me go over what I've done so far. I made some really good, I had a really good accomplishment yesterday, which was a huge improvement on the model. It's the first thing I think I have working decently, so I'm going to work more on fine-tuning that today and adding some more data into my database. So before I start, please subscribe. Go to the GitHub that's in the description. Download the code that I have. Try it out for yourself. You can make basically any model that you want to. I have all sorts of features and targets. And if you know a little Python or you're willing to use an AI model, you can build your own model like I'm doing here. If you use the GitHub, please don't forget to star it. Follow me on GitHub. Watch the repository. All of that really helps me out. Also join the Discord. All of that stuff is in the description. So let me go over where I'm at. So this is the outline for the model. Basically, I have data containing all stocks going back to 2011. This is including stocks that were added to the stock market and also ones that dropped out. I want to use this to isolate a universe of stocks, so I don't want to use all stocks. If I'm using penny stocks or stocks with really low volume, that's going to throw the model off. So I want to trim it down to really good, reliable stocks that I can use to train my model. So once I have that universe, I want to feed that into the model. I want the model to run and train on this universe and spit out some good results. And once I have a model that's working well, I want to feed this into a portfolio model, which has some allocation strategies. And this will be optimized to make money. This is optimized to predict returns. So the first version I worked on this was fairly successful, but I felt like it was successful. It was a good first iteration, but I knew that I needed to improve. Oh, hold up. I don't think my screen's updating. Just a sec. Let me fix this here and get my screen to be live. This is going to take just a sec. Mac OS screen capture. Okay. Switch to the other screen. Okay, there we go. And yeah, okay, now this is live. And I just got to put my face in front of it. Cool. Okay, so this is the first iteration of the model. So I started out getting data from SPY, the NASDAQ website. This is ultimately inefficient because you need to download the CSV of every stock for every day, and there's no way that I'm going to do that. I want something really clean and simple that I can automate. I just want to run a script some point after the market closes and before the market opens the next day, and get picks. So that's one thing. The other thing is that I want to make a model that's usable for anyone. Like I said, it's in the GitHub in the description. You can go get it for yourself and train your own models without having to know anything about machine learning. You just have to try out different features and targets. And so those are kind of my two goals. So they kind of are aligned with each other because it needs to be clean and simple for me to use. And that also will make it usable for anyone else. So that was the problem with this data, is that you can't really automate this. I found a better data source that's also in the description, and there's also instructions for installing it on my GitHub. Basically, it's a SQL database that has all stocks going back to 2011. I did some basic analysis here. So this is qualitative. Here I'm looking at fundamental indicators on the black chart. This is showing how different stocks performed in a sector, in this case the pharmaceutical sector. And this is nice, cool to look at, but it's all qualitative, not quantitative. But it is better than stuff you could find on Yahoo Finance. So I went ahead the problem with qualitative analysis is you can't really automate it. I want something quantitative. So I created a light gradient boosting method model. I was able to get it to give back 51.5% directional accuracy, which wasn't bad, I thought. I did find a portfolio strategy that worked with this, so my goal is to beat the S&P 500, not just barely beat it, but beat it by a fair margin. I also want to be more robust than the S&P 500, so if the S&P is going down, I want to be making money still. And so I found that if I'm looking at the bottom n number of volatility stocks per day, the lower n is, the better it performs. So if I did the 500 lowest volatility stocks, it's underperforming SPY. If I trimmed that down to 100, it basically matched the S&P. If I trimmed it down to 20, it's beating the S&P, and 1 beats the S&P significantly. I then looked at, if I change n, what's the Sharpe ratio? You want a Sharpe ratio above 1 for your model to be useful. And so only making one pick per day was the only one that gave a useful model. I then tried some thresholding and found that I could increase the Sharpe ratio significantly. 0.5, it's giving about 1, 0.51, also 1, 0.52, still no improvement, but 0.53, suddenly there's an improvement, and 0.54 gave a really high Sharpe ratio of 2.5. The problem is still that this is picking one stock per day. Oh, and if I increase it to 0.55, it wasn't picking anything. So I decided this all comes back to the model. My model's not good enough, and 51.5% returns wasn't good enough. I wanted something that was 53 or 54%. And so what I had to do next was go through and rapidly iterate on different features and targets and strategies for the model. Also strategies for the universe and the portfolio strategy. The problem was at this point, so this was my work for January. This project I started at the beginning of the year, so it's kind of my project for the year. I'm trying to do a live stream every day on it and work on it every day for at least 1 hour, and that way I can make some progress. So this was where I was at the end of January, this model right here. And so before I could rapidly iterate on things, I needed to restructure the code base because it was organized really poorly. It was dozens of files, and it was going to quickly blow up into hundreds of files. So I spent February reorganizing the code base. Oh, and the problem with hundreds of files is it's not going to be usable for me or anyone else. So remember my second goal. I want to make a tool that anyone can use. So during February, I reorganized the code base into something that's clean, flexible, simple, and diverse. So I had the data already. I added in some filter classes for the data and fed the data and the filters into a stock universe. That's its own class. So it's flexible. You could define it any way that you want. I then made some feature and target classes and fed that into the returns model. And I made a class for the returns model. I don't have a class for the portfolio model yet, but that's because I'm still working on my returns model. And these are all the features and targets that I added. So like I said, I added everything that I thought could possibly be an interesting feature. So once this was done, I went through, added all the features, and then I got the model working. The first thing I did was add all features to the model. Basically, this is all just kind of an exploration, hunting for good features, and I wasn't able to find anything. And so this is all trying all sorts of different things. I'm able to rapidly iterate now because I have a clean model. And this was kind of the first good thing that I found, is that the further I look out into the future, the better the model performs, which kind of makes sense. Getting returns on a single day is really hard. One, because that's what armies of quants are working on. But two, lots of the movement that happens in the market is happening after our hours or in pre-market trading. So when institutions are able to buy and sell, but retail traders like us aren't able to buy and sell. And so if you're just doing 1 day returns, you're missing out on all of that action if you're trying to buy at market open and sell at market close. You also have slippage and fees. So all of those things kind of make it a lot harder to make money. However, if you're looking into the future, not only are you making less trades, so there's less slippage and fees, but also you're able to kind of get that the after hours and pre-market is kind of incorporated into those 5 day returns for every day. And so you're not missing out on things as much. And so then I went through, tried a bunch of different things. I still wasn't able to improve the model much. And so this directional accuracy is a lot better. But I also started looking at the Spearman information coefficient. And although the model return was looked really good. Like I said, my initial goal, the initial model, I was getting 51.5%. My goal to improve on that was to get 53 or 54%. And you see here, I'm getting basically 53, and here I'm getting 54%. So I thought that's a good enough model. But then when I kept looking at it, I found that I needed to assess the model not only on the directional accuracy, but more important is the information coefficient. And I wanted an information coefficient of 0.1. And you see that none of these are achieving the information coefficient I want. And so not only do I want to add the information coefficient, I went through and looked at what are some other metrics I can add. And so these are all of the metrics that I'm looking at right now. Root mean squared error doesn't matter. Directional accuracy, I actually decided doesn't matter for the model that I'm training. But what does matter a lot is I need this information coefficient to be 0.01. I need the standard deviation of the information coefficient to be orders of magnitude less than the information coefficient. That basically shows that this is stable and not just I didn't get lucky in getting the information coefficient. This is a really reliable result. I also looked at the ratio of the information coefficient to the information available. And I looked at that over each day and then also annualized that. And then I looked at the information coefficient t statistic. So yesterday, the problem with some of these features, like the standard deviation of the information coefficient and the information coefficient to information ratio and also the t statistic, the problem is that if you're doing on 5-day future returns and you're not isolating the data in the test, then you're artificially inflating these values. Because if you think about it, 5-day future returns, if you're starting Monday, the 5-day returns will be going through the next Monday. Same thing with Tuesday, it's going through the next Tuesday. So the data on Monday to the next Monday and the data on Tuesday to the next Tuesday, well, those are sharing four days. And so they're highly correlated. So you're going to get these values artificially inflated. And so I went through yesterday and I changed it to separate that and get realistic values for these. And then yesterday, this is my big breakthrough, is I was able to get a model which appears to work well. So if you look at here, this was the output of the model. And so the directional accuracy is barely better than a coin flip. But like I said, I'm not paying attention to directional accuracy anymore. And if you look, so the information coefficient is 0.02, which is really good. If you look the information coefficient standard deviation, that's the one problem. That's the one thing I need to get down. So you see the standard deviation is actually higher than the information coefficient. However, the ratio of information coefficient to information, that was the value I wanted. And then also the t statistic was a sufficient value. So this looked like a really good model. And then if you look at this, the estimated annual Sharp ratio is 1.9, which is, like I said, you want a Sharp above 1 to show that your model's usable. 1.9 is really a tremendous result. And so since we're not paying attention to the directional accuracy, one way to kind of look at how this model's performing is to divide it up into quantiles, or here I called it quantiles, but these are deciles, so I broke it up into percentage. So if I'm picking the bottom 10% of stocks, this is the mean actual return for the next 5 days. So the bottom 10% are on average returning a point above a 0.0, below negative 0.04 log return. So really negative. And then what you want to see to show that this is a stable model is that as you walk up the deciles, the model improves. And so you see here it's not perfect, like 30% is overperforming 20%, but it's underperforming 40%. But the shape of this is correct. And if you look at the, once you go above 50%, 60% is worse than 70%, is worse than 80%, is worse than 90%, is worse than the top 10%. And so this was like a really good result. I'm going to build on this today and see if I can improve this even more to be basically a perfect staircase. And if I get that, So that's the things I'm shooting for today. Is I want a perfect staircase, and these values are all good except the standard deviation of the information coefficient. So I need to get that down. Let me put a comment in the chat real quick. So subscribe if you think this is interesting. Go to the GitHub, start the repository, download the repository, follow me on GitHub, watch the repository. All those things really help me a lot. Helps raise my profile for coding jobs. Okay, so, and also I would appreciate your feedback because, I want to make this a useful model that anyone can use. So, here are the things I have to do. These are my to-dos basically to make the model more robust. So, let me pull up Google AI Studio. And before I get started incorporating all of this stuff, I want to look at, I basically want to feed it this and say, how can I improve on this? Because it might have more suggestions other than the to-dos that I have set out for myself. Okay, so I am assessing my market return model. Do I still have stuff here? Yes. Here are my results. And here is my decile analysis. In picture. Okay, so what else? Oh, hey, I didn't see all these comments. Hey, Tyler. Yes. Well, I mean, I don't know. Do I do ML engineering? That's basically what this is. I don't do it for work, though. Hi, G Spider. I also, the quant, like to connect with you. What is the best way other than the YouTube? Go to the Discord. That's the place. Hey, I'm a software developer. I myself had tried developing a bot for the stock market as well using XGBoost. Would love to connect to understand more on quant. Yeah, I mean, go to the Discord. Join the Discord. We need more people in there talking about stuff. I want to talk about quantitative analysis and all sorts of other things. History, politics, anything that possibly could be interesting. Philosophy, science, physics. So join the Discord and start talking about stuff. Start talking about anything that's interesting. Mix of research and coding. Yeah, that's what I kind of like about this. I do physics research for my work, so yeah, that's what I think is fun. I like, this is what I do for work, research and coding. I like doing research and coding in my free time too. That's why I really like this project. My work-life balance, I would say it's really good. Well, it'll be a lot better. Right now I live with my parents because I plunged deep into credit card debt. So that's your warning. Never do that. But you'll ruin your life for a little bit. My life's actually going really well though. But all that to say is that I have an hour and a half commute to work. So my work-life balance, I don't know. I spend 3 hours of my life driving to work every day. But my work is really fun. And then in my free time, I work on this. So I don't know if you would call that a good work-life balance. I like it. You're not asking me. You're asking G Spider. Not so good. Yeah, I'm sure for quants, or are you asking Keon? Well, quants and software developers, I don't think have the best work-life balance. That's the stereotype, at least. At what you are there in the Discord. I'm not sure what you mean by that. At what time are you there in the Discord? I just check it. I mean, I check it infrequently, honestly. I don't go to it that much because people don't talk about stuff in there. So I've tried to get some conversations going, but people haven't replied. So reply to the stuff that I said, or, just literally just start discussing something interesting and I'll start going there more. I'll be there all the time if there's interesting conversations going on. I'm trying to upskill in AI engineering as well. I'm a full stack dev. I'm kind of bored and looking for new things to try out. Yeah, dude. I mean, AI, like optimizations, you could do basically anything you want. All right, so let's get down to business. Here's my decile analysis. All right, so let's say all metrics are above my target thresholds, except for the standard deviation of the information coefficient. I want this value to be orders of magnitude smaller than the information coefficient to prove my model is robust. However, it is larger by an order of magnitude. Okay, what else? Okay. Also, the decile analysis appears qualitatively appears like I'm moving in the right direction, but is still not a perfect staircase. Oh, hey, so Tyler, you're the perfect candidate. Download the GitHub repository that I have. It's in the description, and try to use it. Let me know. I've made all sorts of apps for work, and so I basically have coded all sorts of things, but it's for science people who have an aversion to coding a lot of the time, and so they're just happy to have something that works. So I'd really like some feedback. This is the first app I've built that I really want people to use. So give me some feedback, try it out and give me some feedback. How can I improve? Especially as a developer. I'm not a developer. I've taken like one coding class. I'm self-taught, which means I don't know lots of best practices. So I'd really appreciate your advice. I want to know how much more in quant are you free in nighttime? I'm not sure what that means. How much more in the quant are you free in the nighttime? Hey, Sir Night Night. How are you doing? The decile analysis is moving in the right direction, but it's not a perfect staircase. Assess these issues. Explain why they are happening. And provide suggestions for how I can improve my results. Okay, so now I have all of these to-dos. Let's see if it tells me anything other than this stuff. And if it doesn't tell me anything new, then I'm going to go ahead and add fundamental features to the model. Okay, let me put some music in. Yeah, honestly, last night after I got a good result, I was floating on cloud 9 today. Work went really well today. Work went really well the whole week, even though I kind of got beat down because I did so much stuff. But when I work a lot, when I work like 10, 11 hours each day, and then I get some really good stuff done at the end of the week, I feel amazing. If I'm working 10, 11 hours each day and I don't have anything that I feel like if I don't have anything done at the end of the week, I feel terrible. So it's the former for me this week, and I'm on cloud 9. I want to know more about the quant field, much more about the roadmap. So are you free in the nighttime just for... I mean, honestly, I don't even know anything. I've learned everything in the last, like, few months. Just try making a model. Just ask AI, hey, how do I make a model? And just go from there. Take its suggestions and try to improve, try to iterate. Yes, I keep burning the midnight oil. Because I don't know. That's how it goes, I guess. Oh, you just had your second kid. Congratulations. You said a baby was on the way. So congratulations. Everyone say congratulations to Sir Night Night. Wow, that's a big life milestone. So congrats. Um, oh, you're paper trading next week more. Well, good luck. I hope it goes well. Oh yeah, I was gonna put some music in. All right, time to focus. Let's go. Tell me what I should listen to. Give me some music suggestions. No one's giving me any music suggestions for several streams, so I'm listening to the same old music. It's warm in here. I gotta take my sweatshirt off. Which AI you are using? Is it Gemini? Because the UI is different. Different from what? Yeah, this is Gemini though. Oh, well, you want to go to... Some user told me to do this, and this has been really helpful because this is the most useful AI model I've found that I don't have to pay for. But they limit your requests. But go to Google AI Studio, and they have Gemini 3.1 Pro. I think if you just go to Google Gemini, use normal Google Gemini, you're not getting the Pro version. You're getting the fast version. All right. Based on the metrics and the visualizations you provided, you have built quite a promising model, blah, 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 blah. Here's an assessment of why these issues are happening and how you can improve them. Man, that's like the one... Jazz is like the one genre of music I'm not really a fan of. That and like big band. I don't like big band either. That was my grandpa's favorite genre. He was born in 1923. But I was never a big band guy. Okay, you want the robust IC standard deviation to be orders of magnitude smaller, but it's currently larger. Your expectation is entirely unrealistic. Oh, whoa, 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 whoa. So this says it doesn't have to be smaller. So let's look up information coefficient, standard deviation, stock model. You said I'll probably send you some pics, and I'm like, hell no. I've been waiting, hell no. Really? Okay. In reality, the realized ICs may have serial correlation since the predictors used in a model are often impacted by market cycle. This may affect the estimate of the standard deviation of the mean IC and consequently hypothesis testing related to the ICs. However, the serial correlation of realized ICs is found to be small. That's not what I want. Oh, standard deviation. Did I watch Harry Potter? Yeah, I've seen. I haven't watched all of them. I've seen the first one. I've seen the second one. I've seen the. What the hell is the one I saw as a kid? The third one. But what is that one? The one where there's like the flying car and the tree and shit. Prisoner of Azkaban. And I've seen the fifth one. I think it's the Goblet of Fire, but I haven't seen the other ones. I was never a big fantasy guy. I like things that are real. That's always what I've liked. When I was a kid, I liked baseball more than anything else. Big baseball guy. Um, Table 5, we report the standard deviations for some industry studies. Hey, nice. So, information coefficient, they're getting these. Oh, come on. What kind of fucking table is this? These trading, or I guess they're quant papers, they really suck. Information coefficient is a performance measure of stock selection models. Wells Fargo and Company. That's what I should do. I should get a job for a bank. Actually, I probably shouldn't. That might not be ethical. God might not like that. Where's their big fucking table? Their big table. See, these are good tables. So they look like they have a nice staircase. Here's the shit table. What is this? Copy and pasted from something? Here it's larger by an order of magnitude. Here it's larger by 9 times, maybe 8 times. Okay, so larger, 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 way larger. Oh, yeah, larger, 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 larger. Okay, let me put this into my PowerPoint. Also, Sir Night Night, it's Friday. This is the best night of the week to burn the midnight oil. I could burn it till it's completely gone. In the Goblet of Fire, Barty Crouch. Yeah, I have no idea. Oh, I remember that. That was like the big drama in Goblet of Fire, right? Forces Harry to participate in the Triwizard Tournament. He puts Harry's name. I don't know. I mean, it depends on what the rules are of the Goblet of Fire. Maybe how the Goblet of Fire works, that's a reasonable thing to do. I really don't remember that much. I'm not sure if it's ethical. Tell me, what are the rules of the Goblet of Fire that surround that? And we could figure out if it's ethical, in my opinion. Retail investors cannot use... Yeah, this is the whole point. I'm a retail investor. Yeah, you can use quantitative trading. That's the whole point. We want to make money. We want an advantage. Download the repository. You can make your own quantitative method. Alright, so I'm just going to say previously I wanted information coefficient standard deviation. Oh, I think that I found myself a cheerleader. To be orders of magnitude smaller than the information coefficient. This is incorrect. Alright, what the hell are these guys? Feng Chang. Alright, Chang 2020. All right, and I need to put references in here because I should have put reference for the first paper. Think that I found myself a cheerleader. All right, so we want to put authors, year, title, link. 1, 2, let's just put as many as possible. Oh, I think that I found myself a cheerleader. Chang Guo Kao. 2020. Information coefficient. Oh, I think that I found myself a cheerleader. As a performance measure of stock selection models. When I need her. All right, good. And real quick, let me put that other one in. All right, Bisdulis. That I have no idea how to pronounce. Biduli or something. This guy's not even gonna say what fucking year it is. Come on, dude. This sucks. What the fuck? Bisdulis. The reason I asked is 2024 asset forecasting. Yeah, 2024. Cool. Assets forecasting with feature engineering and transformation. Methods for LightGBM. Guess this should be lowercase. Okay. Chang 2020 shows the table at right from of historic studies shows the table at right of standard of ICs and their standard deviations for historic studies. All standard deviations are significantly larger, usually by an order of magnitude. Okay, so let's put in a note here. Can be larger by an order of magnitude. Hey, Deshant. Why not just go to Archive or Alpha XIV and get all the papers that we need? Well, I don't know. I don't know what are all the papers that we need. Do you know any? Link them if you know some. I have no idea what papers we need. I just looked for stuff. I don't have any more papers. That's all I've got. The reason I asked is one of the person I know created a chess account of another person by giving his email ID, and now he's making the other guy play chess on that website. Wait, what happened? Someone stole his email and he's making the other guy play? How's he making the other guy play? Can't he just not? Why? He's being forced. Is he being held against his will and forced to play chess on an account that isn't his? I would say that's unethical. Alright, so does this guy say anything else after he gives the table? Where's that big fucking table? It is clear from the table that the realized ICs are volatile. Of about 24 models covered, with an exception for the multi-factor model, in the last row, the standard deviations are at least 3 times as large as the means, suggesting that a symmetric IC distribution would put a significant portion of the ICs in negative territory. Suggesting that a symmetric information coefficient distribution. Oh, right, because the standard deviation. Yeah, right. So if it's symmetric, given that the standard deviation's larger, a chunk would be negative. A chunk would have negative information coefficients. More importantly, the time-varying component dominates the static component and driving the IC changes across time, accounting for about 95% of the total variability. This result clearly underlines the great difficulties in relying on the realized ICs to monitor ongoing performance. Okay, good. Here, now they address it. No, I'm not a CS major. Yeah, it's a side quest. It's for fun. Yeah, exactly. If I just go look for random stock market quantitative analysis papers, there's going to be all sorts of stuff. I need to be looking for something. I need a problem that I'm trying to solve to look for a paper. I don't want to just read papers. All right, so I'm going to read this. Might not be the most interesting live stream content, but okay, we propose 2 alternative procedures for using realized ICs to monitor the ongoing performance. Good. First focuses on the behavior of the average IC. As shown in section 7, this is section 7. The standard deviations of the realized ICs are very large relative to the mean. You mean section 6? What is this paper? Does nobody review this before they publish it? It would be extremely difficult to draw any conclusion about the underlying IC if one only looks at the current or otherwise a limited number of realized ICs. The performance of the underlying model should thus be evaluated based on the realized ICs over a reasonable period of time. Depending on the data availability and following some convenient conventions, one may define a reasonable period of time as the last 6 months, 12 months, or 24. Yeah, okay, several. Yeah, whatever. An average realized IC. Oh. Reference 10. What is that? Oh my god, are you kidding me? They cite reference 10. There is no reference 10. What is this crap? Okay. The choice of row knot can be tricky, although some practical guidance may be available. I have no idea why that's better. Average it over 6 months. I did average it over... I averaged the ratio over a year. Yeah, I mean, depends on what we want, but we're unclear, so it makes sense to just search everything. Well, what am I going to do? Read every paper that exists on quantitative analysis? Why? Yeah, I don't get that. Yeah, my response to that, I was totally confused. I'm dubious as to whether that's a real thing that's happening. Is somebody stole somebody's email and made a fake chess account? And I'm dubious because how could he force the other guy to play? Some of the people who write this stuff have no idea what they're talking about, and you might find you disprove some papers. Yeah, these kind of suck. Also, what is he even saying? They're like, use the average over the last year. I don't even know what to make of that. Yeah, it's definitely advisable. Programming's easy with AI. Just download the repository, go to whatever your favorite chat model is, and give it the repository. Just say, here's the repository. How do I use this? Yeah, but actually some places say that it won't. Tell me about this repository. Some places say we can't get it, so you might need Microsoft Copilot because Microsoft owns GitHub. Don't forget to star it. Go to the repository, star it. Follow me on GitHub. Watch the repository. Fork it if you want to make some changes to it. All that stuff really helps me out. So let's see. Can it look at a repository? Because if it can... It looks like it's reading it. So assuming this works, just go to Google AI Studio, give it this prompt and say, how do I use this for myself? And it'll tell you. It'll even write code for you. You know, write code to make me a model. Does not appear to be a publicly available repository. That's not true. It is public. Hey, it's looking at my models. Yeah, so I guess it can't. You're gonna have to go to Microsoft Copilot. My friend wants more people to play chess. How does he get more people to play chess with him? I don't know. Make some friends. Join a chess club. That's what I would say. Join a chess club. All right. So that is this gonna really help at all? Use the average over years. I don't know why I would do that. Take the binomial distribution for the number of 5% rejects. The second procedure that one may use to monitor model performance on an ongoing basis builds upon the average IC test described above. It takes the outcomes, rejecting or accepting the null hypothesis from the monthly hypothesis testing exercise and evaluates the outcomes over time. Okay. To illustrate, suppose the monthly hypothesis testing is based on a significance level of 5%. If the null hypothesis is true, there's a 5% chance of rejecting it. Assume that all tests are... Oh, IID. Independent something distributed. I forgot what that meant. Also, yeah, what kind of paper is that they use? Usually you define abbreviations. Let's see how many citations this has. Yes, slop has definitely increased significantly. Yeah. So yeah, you got to use Copilot if you want to look at the repository, but try that. Yes. Oh, well, if you get a fork in chess, you're golden. You must be a big chess fan. Yeah, that's what I've noticed is they don't answer stuff with repos. Oh, that's a great tip, Sir Night Knight. That's true. If they write a book, it's way more, um, way more hashed out, edited a bunch of times, ruthlessly criticized to make sure it's useful. Cited by 8. Okay, so that doesn't count. That doesn't count. They're just looking for every fucking AI paper, AI investment. They just Googled it, counted all the papers. Yeah. That's not going to be useful. All right, get out of here. That table was nice, but everything else was crap. So based on the metrics, okay. So it said will be good. Mean rank IC of 0.02 to 0.05 is considered standard and highly tradable. Standard deviation of 0.08 to 0.15 is normal. Okay. Information ratio. Markets are highly efficient and driven by countless unpredictable exogenous factors. Your model is extracting a slight edge, 2.29% correlation. Oh, yeah, okay. But period by period, the noise will frequently overpower the signal, leading to a high standard deviation. The non-monotonic decile analysis, the staircase issue. Your concern, yeah, I know my concern. The assessment, well, a perfect staircase is the theoretical ideal. It is rarely achieved and is not strictly necessary for a profitable strategy. Your model is exhibiting a very common behavior. It is excellent at identifying the tails, but struggles to rank the middle. How to improve your results. Even though your results are already good, if you want to smooth out IC volatility, improve the monotonicity of your deciles, try the following techniques. Switch to a ranking loss function. If you're using a tree-based model or a neural network, stop using, I'm not using root mean squared error. Switch to a ranking loss function like pairwise, lambda mart, or list MLE. Factor neutralization, I already did that. Try neutralizing your target variable or your features against sector and bearer risk factors. What is that? Oh, I need to add, yeah, physics research. Yeah, actually, Sir Night Knight, that's like, kind of like I feel like my big advantage here is because I'm always looking at papers. You kind of get used to it and you kind of go to what's useful and discard crap. Which really the way to do it, I think the best way is if you know Richard Feynman, he says go to the conclusion, read their conclusion, and then try to figure out how they drew that conclusion. I do that, and I also just look for plots and tables because that, they say a good paper really the plot should explain itself. You shouldn't need any other explanation other than just looking at the plot, and it should be self-evident. So factor neutralization I already did, but I gotta know what the hell a Barra risk factor is. The hell is MSCI? Okay, it's some company. Decompose portfolio risk into over 40 specific metrics across 3 main categories. They are used for, but not limited to, risk management and portfolio construction, providing a single value at risk number. Key components. I forgot, I need to add sector information into the model, so I'm going to add that to my to-dos. Let's move this up. Okay, bearer risk factors. Let's make this 2 columns. Yeah, that's what I always say. Oh, Jim Simons is a physics guy? I always thought he was a math guy. The thing about physics is just like understanding a complicated system, and lots of people like go into understanding complicated systems like that's everything is a complicated system. But the problem is lots of complicated systems aren't real; they're just made by humans. It's all this abstract bullshit. A bureaucracy is a complicated system, so you could become the master of bureaucracy, but it's not real. Nothing's real. It's just a bunch of crap, made up crap. And physics is real. That's the one thing it has, is it's always real. Same with math. If you're willing to accept that numbers are real, then all of math is real. Borrow risk factors, Python. So is there some package where I could just implement all this crap? This rep is a simple attempt of... It's an attempt? Okay. That's enough of that. Okay, I'll just ask. Ensembling, bagging. High variance in predictions can be smoothed out by ensembling. Instead of one model, train 10 models on different random subsets of data or features, or blend an XGBoost model with a deep learning model. The blended predictions will have lower variance, which usually reduces the standard deviation. Feature orthogonalization. Check if your features are... Oh, yes, I need to do that. Highly collinear features can make tree-based models unstable, leading to volatile predictions from period to period. Use PCA or Graham-Schmidt orthogonalization. All right, let's look those up. And physics is also constantly, it's like, oh, somebody made some like model, somebody has some math model for this, and then you just look at it and try to figure it out. What the hell was it called? Graham-Schmidt. I used to suck at physics, not gonna lie. I picked up CS because it had a bit of math and not physics. That's the key, is everybody sucks at physics. Nobody does good at physics. When I was in college, you would get the tests back, and the professor would give the statistics on the tests, and the average would always be like 45%, and then they just curve you up. So nobody gets it. You just got to keep hitting your head against the wall. But CS is cool, but now they say computer science is the most unemployed major. Jim definitely stepped into physics for sure with the math he was doing. I had no idea. Honestly, I don't know much about him. Is there a good book on Jim Simons? I've just watched a number file video on him. Oh, just a question. Principal component analysis in Gram-Schmidt process. But PCA finds optimal directions, maximizing variance, while Gram-Schmidt covers a set of vectors, converts a set of vectors into an orthonormal set. PCA is ideal for dimensionality reduction, feature extraction, whereas Gram-Schmidt is used to construct an orthonormal basis. Okay, so let's use PCA. Add fundamentals, add transform to better residualize, improve LGBM. Okay, simplify LGBM. That I already answered. So we're going to say does simplified LGBM improve results? A lot of them are losing the jobs, but those who know how to position themselves and just jump into new things always get paid well. That's exactly right. That's how it goes for everything. It actually really doesn't matter what you major in college. What matters is that your brain is flexible and you're not afraid. That's actually what I figured out about math, because I never cared about how my grades were in high school. I did really poorly in high school, but I just kept going up in math, and so I ended up with all these, all the AP kids. I was in their classes, but you just keep hitting your head against a wall, and the key is to not be afraid of anything. You can't be afraid of anything. You just got to put your head down and learn it. Like Sir Night Night told me last night, you can't be afraid of big things that are over you. You just have to put your head down, learn it, and go to battle. Does simplified LGBM improve results? So, where are those suggestions? What the hell? Oh, why is this down here? Oh no, that should be at the end. Suggestions. Hey, Node. NO3DE, is that pronounced Node? From that quick review I did not necessarily understand why you choose PCA over Gram. Oh, basically, PCA is best for feature. What I'm trying to do, I'm trying to drop out features that are correlated to each other. So PCA is best for that. PCA just maximizes variance. SF is going crazy these days, hundreds of new startups every day and hundreds getting killed by new models and features by Claude and OpenAI. Yeah, well, it's an exciting time. Things are exciting. When I was a kid, I always thought, I wish I lived in an exciting time. And what could be more exciting than this? I guess I should look more into the PCA thing, but I'm not going to do that right now. Now I'm going to try simplifying the LGBM. So let's crop out the top crap. Okay, so what are the suggestions? Make model dumb. Max depth of 2 to 4. Min data in leaf. Learning rate. Call sample underscore by tree 0.1 to 0.3. This PowerPoint, are you sharing it anywhere? No. This is just, I mean, this is a giant mess. You don't really want to, I don't want to share this anywhere. People are going to go find it and say, this guy's a schizophrenic. But what I am gonna do once I finalize the first model, I'm gonna condense this all into this is what I do for my day-to-day research. So you put everything as you're working into one giant PowerPoint. See, it's 87 slides. Nobody wants to read fucking 87 slides. But what they do want is a condensed down version. So then I'm going to take, there's all sorts of things that aren't interesting to look at, like this. Nobody wants to look at that. What I am but the key is you want to put all the plots in and everything, and then interesting notes so you can, kind of remind yourself. But then once you are making a presentation to show people, you want to condense it down to like 5 to 10 slides. So I'm going to do that, and then I'll make a video explaining my progress. And I hope by the end of March I'll have a good model, because that will kind of divide things up like very clearly. January, I kind of learned about it, did some basic exploration, and made my first model. February, I cleaned up the model and made it really robust, or cleaned up the code and made it really robust. And then March, I got a model that worked well. PCA just rotates the axis to align with the highest variance. Highest variance. Well, highest variance. That's what I want. I want the features with the highest variance. Features. Oh no. I want low correlation. I need to make like one of those plots where it shows the correlation between each variable. But with all these variables, like 30, how many variables do I have? Like 30 to 50? That would be huge. Like 30 by 30. So I need to do something to analyze the correlation. Time and effort, I mean, this is easy, Well, time, look what time it is. I'm on the west coast of the United States, so the time is 11:10 p.m. So the time, you just gotta make time. And then the effort, it's easy to make the effort. I want to be rich. Okay, so let me try changing the model so it's doing this stuff. So actually, I'm going to move this down to my lower screen so I can read it while I edit the model. That means I won't be seeing any comments for a little bit. Okay, let me put in music and let's cruise. So, clean analysis. So the first thing is max depth. Max depth. So let's make max depth 2. Okay, then min data in leaf. Get rid of that, and let's say 1000. Learning rate 0.01. Learning rate. I'm bulletproof, nothing to lose. Far away, far. Call sample by tree 0.1 to 0.3. Okay, that's not in there. So let's say call sample underscore by tree. We'll just say 0.1. Okay, so does this improve things? So I'll put the value I chose here. So 2. Min data leaf is 1,000. Learning rate 0.01, right? Learning rate. Yep. And then call sample by tree, I did 0.1. I am titanium. Make sure this is saved. Save. Okay. I need some more music to listen to. Does anyone have any suggestions? Future. I have to look. Where do they sell? This is not related, but I think I'm gonna have a beer, but I'm drinking all my parents' beer. So I have to buy them some more. Oh, it's at Total Wine and More? Do they have an inventory? Oh, good. I'll go get a 12-pack. I don't want a can, though. Yay, you get rich and have problems that you never thought. Okay, good. I can have a beer because I can go buy some more tomorrow morning. Correlation, analysis, feature reduction, ML, stock, quant, model. Turn your back. Been blessed. Been in debt. On the mind, I should have did better, but it's chatter. See, so what's their, oh, really? I'm living my second life. It's amazing. I just want to look for like a plot that I'm gonna make. For music, you can listen to Tomorrowland. Cool. What kind of music is that? Minimum wages. Never popped a lady. Oh, Tomorrowland is a music festival? 2025 lineup. When I'm rapping cause I'm raging. I like dance music for working. Yes! Oh, Lose My Mind by Don Tolliver. What kind of Don Tolliver I've heard of, and I've never listened. I don't know. I can't name a song. Don Tolliver is what it sounds like. Lose My Mind. Oh, I don't know. This is. I'll listen to that next. This is going hard. That's what I keep thinking of as a correlation matrix. Got out of bed at all. Oh yeah, well I'm listening to there's a whoa, holy shit. That's a lot of features. So sometimes it trims the features, sometimes it includes every damn feature. That's not going to be a useful plot to put in. I can't even read it. But let me see if I put it on my other screen. Can I make it bigger? Yeah. I don't know what to do with that. This looks about the same. I mean, it's already optimizing the parameters, so... So let's say model 12. New params. And then here is model 12 old params. Okay, so what performed what better? New model has a worse Sharp ratio, but a better spread win rate, lower mean target daily spread, T statistics worse, ICIR is worse for yearly and daily, standard deviation is higher, robust mean rank IC is lower. So we can draw a conclusion. I think because it's already optimizing to find them, so new params perform worse. Use old params. Okay, so that's the first suggestion. What's the other suggestion? Correlation analysis. But this still looks okay. So let's go back to the model. Yeah, so if you go to the GitHub, you can make features like this. Feature request, and then you define your feature. There's a list of features you can use in there. I gotta organize this, make a website or something that explains all of this. Feature selection and EDA. What is EDA? EDA has to most of the difficult things when it comes to ML and training models and doing all sorts of stuff. Are you saying Are you saying feature selection is one of the most difficult things to do? Oh, exploratory data analysis. Well, that's not good. That doesn't make me hopeful. Yeah. So let's think. How do we do this? What is this called again? Correlation matrix. I mean, we could leave out the, let's see, so... Okay, so the first model is all features, so... I can add beta now. Because it's not referencing data inside the universe anymore. So the problem was I wasn't able to get beta. Yes, most important as well. Well, that's always how it goes, right? The hardest thing is the most important. That's good, though, because that creates a bottleneck. Other people aren't going to do it. Target, add features, add target. So split data is what gets the features. So instead of test model 1, this will be if get feature correlation matrix is true. Do this. Okay, so now... Oh, actually, we don't need to do any of that. We could just say engine is equal to feature engine of features. The market has regimes. The regimes determine your features. Oh, okay. The regimes determine your features, but that means I want to split the data up into different regimes. But that was already my hunch of what I had to do anyway. Okay, good. I like it, Sir Night Night. I like all these tips. Market regimes. Define. Useful. Features. And it disappeared. Sir Night Night always coming in clutch. Okay, so to my to-dos, I'm gonna add define market regimes and split data accordingly. Is there an easy way to automatically make a correlation matrix in Python? Yeah. Oh, really? Markets are becoming more efficient because everyone's applying AI to them. Really? I was thinking of regimes defined as like a bear market, bull market. We entered a new regime this year. Well, that's not good if I'm training on past data. Suddenly, this isn't going to work so well, is it? Yes, creating a correlation matrix in Python is incredibly easy, depending on whether you just want the raw numbers, a nice visual chart, or a fully automated report. No, I don't want a fucking Jupyter notebook. That's all I have to do? Okay. And then df is equal to engine dot feature engine. I forget what the method is called. Dot compute. Okay, engine dot compute df. What do I call it here? Oh, universe data. So now we have the data frame. Now we're gonna say get data, get feature data. And then we could say feature, we'll say non-feature keys is equal to key for key in universe data dot keys if f not in key dot split, and then split the key on the underscore. And then we could say df dot drop calls. I always forget how to do this. Pandas drop columns from drop columns by name. Dot drop. Drop non-feature keys. Okay, so now we've got the non-feature keys. So we've dropped the features out of the data set. Drop everything except features from data set. We've got that. And then create correlation matrix. Okay, now you get the correlation. Okay. I don't know, is this gonna work? Let's try it. So we'll turn this guy to 1, turn everything else off. Good. Okay, so let's see if we could get the heat map correlation matrix. Okay. I'm going to go get a beer. I'll be right back. And hopefully when I come back, the correlation matrix will be here. Uh-oh. The correlation matrix didn't work. All right, what's the deal with that? Hey, Soul Water. Welcome back. What was I gonna look? Oh. We want to know why the hell isn't this working? But first, I need to put on a sweatshirt. All right, let's see. What's the deal here? So you need to specify the axis probably. Is it axis 0 or axis 1? Run it. It's not really cold at all. I just run cold. I don't know what you call that. Cold-blooded? I guess I'm cold-blooded. No, but it's not really cold. It's pretty warm. Let's see. Oh, I don't want to show where I live. Oh, well, we'll look up Los Angeles weather. 66 degrees. That's how I feel when I have a hoodie on. I feel like I mean business. I swear it has some psychological effect. It makes me feel like I'm focusing better. No, yeah, it's 66 degrees. But like I said, I run cold. Okay. So we need to do axis 1, not 0. I really mean business when I get a beer. That's how you know things are getting serious. No, yeah, I know. I'm just kidding. But they say it's like a cool thing to say. You say that guy's cold-blooded. Have you ever seen? Oh my gosh! It was 2020. It was 15 years ago today. Have you guys ever seen that famous, if you're college basketball fans, that famous Isaiah Thomas play where for the Washington Huskies, where it's Gus Johnson's announcing it's in the Pac-12 championship and they're down. It's overtime. Oh, nice. It's overtime and he hits a what the hell is this crap? Uh, he hits the game-winning shot and Gus Johnson goes, "Ow!" It's what is it? Thomas, he's gonna do it himself. Shake, crossover, step back. Ow! At the buzzer, young Zeke in Washington wins it. Cold-blooded. Anyway, that's an all-time call. I was at that game. Bob Lazar. Bob Lazar. Does he say humans are cold-blooded? Bob Lazar is a funny guy. Did you see Bob Lazar on Joe Rogan? That was a long time ago now. That was like 7 years ago. Bob Lazar. How do I make this plot better? I want the names of my features to fully fit inside the window. Also, what are the numbers at top? Improve so they are readable if they matter. Otherwise, remove them altogether. Tell me why they matter or not. Anatoly Karpov is a cold human being. Is a cold human being. Let me guess, it's a chess player. Yeah, but honestly, I don't even remember. It was so hyped. I used to love Joe Rogan, and then honestly, I think Joe Rogan kind of went downhill. The podcast honestly isn't even interesting to me anymore. But that was the golden age of Joe Rogan, like 2015 to like 2019. Like 2015 to right before the pandemic was the golden age. You could just tune in. It was the best when it was live. That's when I was in community college and I'd just be sitting there. Yeah, I knew it was a chess player. Yeah, you'd just tune in. I would be sitting there like studying or whatever, and then a notification would pop up. Joe Rogan is live. And I'd be like, oh, who is it? And there's always somebody completely random. It's always super interesting. Heaven's got a plan for you. White gaps. Update the seaborne heat map so that the correlation values are inside the cells. They should be fully contained and not spill over. Okay, what else? Seaborne. It should be fully contained, also spill over. Also remove the white spaces. Really? Former world chess champion and now part of the Russian parliament? That's like politicians, just some famous guy becomes politician. The archaeology series, what is that? Like oh, are you talking about like Graham Hancock and Randall Carlson? Because those are my favorite. That's like maybe my favorite piece of media of all time is the Graham Hancock and Randall Carlson episodes. Those are awesome. And yeah, he should have stayed out of politics. That's exactly right. Because what makes Joe Rogan great is that he's open minded. Um, that is what that's what it was all about. It's like, yeah, he's not some like super genius, but he can have super geniuses on, scientists from all over the place, all sorts of fields, and he just asks some questions and he goes, oh, that's interesting. And because he's so open-minded, he was always able to like pull out what the interesting questions are. It's like it was basically like listening to him was like basically almost like talking to an expert in something, because it was like that's the question I would ask. But also what made him great there is, I think if somebody's too smart, they're always trying to like formulate their own ideas, and like when they're talking to someone, they're formulating ideas and going, oh, well, what about this idea, what about that idea, not just asking questions. And he's like smart but not like a really high IQ. I saw on Instagram once he posted his IQ was 126, so there you have it. 126 IQ guy, not 150 IQ. But that's what made him so great. But then when he started like getting into politics, it's like that's not like a realm for low IQ people. And if you're low IQ, you just kind of, if you're low IQ, you like pick a side in politics. Basically, you become a Democrat or a Republican, and then you hate the other side. And what I always think is, I know I'm in the right spot if Democrats accuse me of being a closeted Republican, and then Republicans accuse me of being a closeted Democrat. That's how you know you're like in the middle, avoiding the morons. Um, I don't like Joe Rogan or Jordan Peterson. They have a vested interest. Jordan Peterson used to have like good stuff. Jordan Peterson, it's literally the same thing as Joe Rogan, except he's like really smart, but kind of shouldn't have gotten into politics. But if you listen to Jordan Peterson like talking about like adventure and stuff, and when he talks about like myths and stuff, and it's like, well, that's the myth of killing the dragon, and you have to go face the dragon and fight it. I think that does all apply to your life. It's just like he's also a bit of a kook and he loves attention. That's Jordan Peterson's problem, is he's an attention whore. Um, well, I haven't listened to that with TJ English and Joey Diaz. Who's TJ English? I mean, obviously everything with Joey Diaz is great, but he kind of gets old for me after a little bit. Journalist. Tour guide through the dark recesses of the known world. I should listen to that. That will be a note. Anyway, that I could talk forever about this, but it really just makes me sad that Joe Rogan Experience isn't good to listen to anymore. I always miss the good old days. And honestly, it wasn't good for a long time, but I still listened for a while after it got bad. Till maybe like a few years ago, and I was like, I just can't handle this anymore. Um, I think everyone has a vested interest to some degree. Yeah, Joe became a different person. Now, you could say the charitable interpretation is he got radicalized by COVID, because that whole thing was crazy to call ivermectin horse dewormer. It's like, yeah, it's that, but it's also like used by humans. It's not, they acted like he was taking horse pills. That was just like crazy. And so the charitable interpretation is that's what radicalized him. The uncharitable interpretation is he got $100 million from Spotify, and what the hell was that for? Was it Peter Thiel? Did Peter Thiel buy Joe Rogan? Because that's the type of shit Peter Thiel does. He buys all sorts of media personalities, and he bought Trump, and all sorts of shit. So I kind of hope it's the former. I'm afraid it's, or I hope it's not the latter. I can't tell. Jordan Duff shouldn't have gotten into politics. I mean, he's just kind of a kook, man. And the funny Jordan Peterson is objectively funny. How he's always getting sick, like every like year or 2 years. He's like, "Oh, I've come down with a terrible sickness," and then I saw like maybe like 6 months ago, his daughter said, "Yeah, Dad." Like Jordan Peterson disappeared from the public eye like in 2025, and his daughter's like, he got a terrible mold infection. Have you seen that? Oh shit. I gotta get to business and stop talking, but this is maybe the funniest shit I've ever seen on Joe Rogan. Is when Jordan Peterson went on and he was talking about like his meat only diet. He's like, I eat only steak, and he's like, it's terrible, it's horrendous. And then he goes, Joe, one time I gotta tell you, I had a glass of apple cider and it was a psychedelic event. And he said he had like psychedelic like nightmares. He acted like he was taking acid or something. And it's like, dude, and it was all from drinking apple cider. It was, anyway, that shit's hilarious to me. That was so funny. Yeah, he does need to take care of his own mental health. He's a kook. TJ Def embrace the Cuban look. It'll make more sense after you listen to the episode. I think Jordan Peterson is intelligent, but he's not intellectually sincere. He initiates an interesting discussion, but never completes it. Yeah, that's exactly right. Yeah, you nailed it. He's fun to listen to, but like, I like, I guess he blew up because, what was it? Some bill that was like you're compelled to call a trans person by whatever pronouns they choose, or you're going to prison, and he exposed it on free speech. That's what blew him up. But also what blew him up is all of his lectures. His lectures from like the mid 2010s, those are really good. I like those. But yeah, you're right. The funniest thing with Jordan Peterson is when he's having like that debate. I don't remember who it's with. It might have been with Slavoj Žižek. He's having a debate with some intellectual, and he goes, well, you have to answer the question of what means. What does what mean? Or something like that. He's then just like questioning, are we going to ask what every single word means? And like, oh, what is that? Jordan Peterson. What have you ever seen that meme somebody made where it's like Jordan Peterson orders at Burger King and he's like, "Well, what is the king and what is the burger? What is a burger? What is a king of a burger? What does that mean?" Jordan Peterson, what does what mean? What'd she say? Oh yeah, is it meaning? Okay. I gotta find it now. And then I'll get back to business. Jordan Peterson. What does what mean? What do you mean?
The question, did that happen, begs the question, what do you mean by happen?
The question, did that happen, begs the question, what do you mean by happen? That's so fucking funny. Anyway. Alright, so what am I doing? Oh, I'm trying to get this to work. Give me some shit that works. Got the correlation matrix. Alright, so now do this stuff. Indent it. Begs the question, what do you mean by happen? Okay, so I want the correlation matrix. See, that's the other good thing about doing projects via live streaming is kind of people comment stuff and then you get ideas and then that was like a nice little break. I got to laugh about Jordan Peterson. That's a great meme. That begs the question, what do you mean by happen? Come on, give us the plot. Oh my god, it's too big again. Alright. So let's see. This is a lot better, but still not what I want. Why are the white spaces still occurring? Also, the labels at the bottom still don't fit. Remove the numbers altogether. I think I might just have to make the fig size smaller. What do you mean by mean? What do you mean by happen? Oh, come on, man. Okay, let's just try making the fig size smaller. So instead of 18 by 14, oh, why the fuck did it do that? That's huge. Let's make it 10 by 10. 10 by 10, that'll be okay. Alright, let's see how that looks. I need music back. Oh, my phone died. That's why there's no more music. Let me plug in my phone. That's better. Whoa, I need to turn the volume down. Don't want to put that there. Since you're building a LightGBM model for stock returns, encountering negative correlations means two very different things. Negative correlation with your target is just as valuable as... Yeah, okay. So we want to correlate with the target. Oh, that's just feature importance, though, basically. How do I perform feature? Whoa. Reduction using the results of the correlation analysis. What is the threshold for what I want to remove? Provide references. Do 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 do. Performing feature reduction using correlation analysis. Damn, I keep shutting off my computer because I hit the fucking HDMI. Okay. Come on. No. That worked. Wasn't expecting that. Okay, so we have 7 viewers. That's pretty good. I'll take this opportunity to say, please subscribe. Please go to the GitHub, check out the repository, and download it. Let me know how it goes. Star it. That helps me out. Watch it. That helps me out. And follow me. All of that stuff really helps me out. And then go to the Discord and join the discussion. Somebody commented, anyone up? A Wild Einstein. Is that someone's name, or is that just what Discord calls people whose name it doesn't know? So we have a good amount of people joining the Discord, but nobody is saying anything. So start discussing things in the Discord. I want to talk about interesting stuff. That seems like fun, but we need people talking in there. So go join it and start talking about stuff. Performing feature reduction using correlation analysis is one of the most effective ways. A general rule of thumb in data science and quantitative finance is to look at the absolute correlation between two features because of correlation. Well, alright, so we'll get the absolute values. Then we have to import numpy as np. There goes that beer. Now the big question is, do I get another? Or do I be done with beers for the night? The big question. So min should be 0. All right. What time is it? Oh, it's midnight. So it's just after midnight. So the stream's been going on for 2 hours. So let's get it going for 1 more hour. And I'm going to have 1 more beer. So there's generally a pretty low correlation. Hey, buddy. So moving average crossover is highly correlated with VWAP Z. Angle 20-day is highly correlated with the trend slope. Well, that makes sense, doesn't it? So the question is, if 2 features are highly correlated, I don't want both of them, but how do I choose which one to remove? Oh. Kuhn Johnson. Free PDF. All right, so where does it say this is? Chapter 3, data preprocessing. Chapter 3. Cell segmentation, data transformations. Removing predictors. There are potential advantages. Hi, buddy. Just a sec. Hey, boy. There are potential advantages to removing predictors prior to modeling. First, fewer predictors means decreased computational time and complexity. Second, if 2 predictors are highly correlated, this implies that they're measuring the same underlying information. Removing one should not compromise the performance of the model. And wait, what? Oh, yeah. Obviously, because they're highly correlated. Might lead to a better model. Third, some models can be crippled by predictors with degenerate distributions. Consider a predictor variable that has a unique single value. We refer to this type of data as a zero variance predictor. For some models, such an uninformative variable may have little effect. Consider a text mining application, blah, blah, blah. How can the user diagnose this mode of problematic data? First, the number of unique points in the data must be small relative to the number of samples. What's that mean, unique values? Collinearity. Hey, that's what we've got. Okay. Classical regression analysis has several tools. Okay. A less theoretical, more heuristic approach to dealing with this issue is to remove the minimum number of predictors to ensure that all pairwise correlations are below a certain threshold. While this method only identify collinearities. More, you'd think this would be better. It's a books or night. While this method only identify collinearities. Why say many word when few word do trick? Calculate the correlation matrix. Determine the two predictors associated with the largest absolute pairwise correlation. Determine the average correlation between A and the other variables. If A has a method for removing features from this guy, Kuhn and Johnson. Okay. God, why is it always asking me this shit? Okay, and then if I get around to generating new features, kind of a good test is you just throw it into the correlation matrix, and if it's not correlated with any other features, then we have better information and the model will improve. Yeah. Okay, so my phone's charged. I can start listening to music again. I'm going to go grab one more beer to finish off this stream. And I'm going to go to the bathroom. So I'll be right back. And when I'm back, we will basically pound through this removal of unnecessary features. So thanks for watching. I'll be right back. Don't forget to subscribe, join the Discord, and star my GitHub. Follow me on GitHub too. Oh boy, we'll go in a little bit. Also, I forgot to mention that it's after midnight, so now it's officially my birthday. So what I want for my birthday is to get rich from the stock market. Alright, give me some song suggestions. Please. It's time to get down to business. So let me put some music on real quick. No one gives me some song suggestions. I'm just gonna find something. I might go back to that, what was it, Tomorrowland playlist. Future. Better not get too comfortable. All right. Let's get down to business. 7 viewers, so don't forget to subscribe. That helps me out. Oh, yeah, and also I should say, don't just join the Discord. Comment stuff in there. We want to get some interesting conversations going. Soulwater, talk about Harry Potter, talk about chess. Talk about that Russian guy you don't like. That would be the thing for the Discord. Put it in the Discord. Why don't you, or just put it in the chat. Why don't you like this Russian guy, the chess player who's what is he? A member of parliament? The Duma, isn't it called the Duma? Or is that in the Soviet Union? What the hell happened? Why did the music stop? Thanks, Sir Night Night. I'm 29. It's my last birthday of my 20s, which could be depressing in some ways. So, I have 1 year. This is all I've got left. I need to make it on the Forbes 30 under 30 this year. That's always been my joke, because I always say I'm going to be on the Forbes 30 under 30. Oh no, I'm running out of time. Alright, so here we go. that'll be my pinned comment. Candles and birthday balloons. Birthday cake, birthday balloons. Alright, here we go. Okay, so I'm going to see how this works, and then I'll add it to the model. No, actually, I could just add, I could just make the model. So I am going to add this as a method to the model. And now in my hand. Yeah, well, we're constantly running out of... A young pup. Well, it's good. Well, that's how I know you're older than me. People who are older than me say that I'm young. Some guy commented on my stream like a couple weeks ago. He said, "Holy shit, you're old." So, when I said I'm 29. But he was a high schooler, you know. What's he know? Gen Z. I'm Gen Z, actually. I'm right on the cusp. By some definitions, I'm a millennial. By other definitions, I'm a Gen Z, so I don't know what the hell I am. Bum bum ba da 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 dum. What the hell's happening here? Come on. Okay, so here, rather than doing this, we're gonna say, okay, rather than computing it, oh. This wasn't even the right thing, but okay, so now I'll make a new model. So if model 13 is equal to true, for now I'll say pass. Was it test? Yeah, test model 13. So 13 is same as model 12, but uses feature reduction from Kuhn Johnson before training. All right, so let's get model 12. Do 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 do. All right, so we have features and target. So get model Model is that. Model split data. And then we'll say applied Kuhn-Johnson reduction. So actually we don't want to return features to keep. We'll say self.data features to keep. So we'll say features to drop is equal to feature for feature in features if feature not in features to keep. And then how do we do the drop correctly again? df.drop, so we'll say self.data self.data.drop. We want to drop features to drop. Axis equals 1. In place equals true. Alright, so we have target, we have universe data, now we split the data. Now let's say model.apply Kuhn-Johnson. Let's make sure we have that turned on. And let's run it. Now let's make a slide. What do I call it? What do I call it? Applying Kuhn-Johnson reduction. All right, now let's add this reference, Kuhn-Johnson. We want to add to our references. Every day and every night. So is it uploaded in 2018 or let's see, what year is the, oh, did it give me a reference? 2013. Oh, I didn't save it. Oh, damn. I didn't change the parameters back. So I think that didn't improve it because I'm already using the trial to determine the optimal parameters. Okay, so model 12, new params, old params. So model 12, all features. Put that up more. Um, I didn't define feature calls. It's defined right there. What line was the error from? $770. Oh, alright. Get rid of that crap. But feature calls. We also need to make this feature calls. Okay, and I think we should be good. Okay. So let's see if we go to the data set. So here's the data set I'm using here. The link is in the description of this video. See, updates every day, updated 2 hours ago. From symbol, where I don't want that. I want OHLCV. Select all from OHLCV where talk to me. Ooh, talk to me. Where account symbol is equal to VIX. So do we have the volatility index? Do you think you're better off? Whatever, that's gonna be a pain in the ass. Let's just go find it. Thanks, Saltwater. It just went past midnight. So it's 12:37 a.m. I guess a little bit past midnight. Okay, what was I doing? Oh, checking the data. Alright, so CD data. Oh, really? 1997? Nice. I'm 6 months older than you. That means I actually have a twin brother, and I used to always say to him, I'm a minute older than you, to brag, and then he would always say, you're going to die a minute sooner. So if that tracks, I'm going to die 6 months before you. Alright, let's go look at the data. So import pandas as PD, df is equal to pd.read CSV, and we want to look at, oh no, not read CSV, it's a feather data set. Oh no, this isn't what we want. We want to go to universes. df is equal to pd.read feather. Do you think you're better off alone? Oh no, we want 2 because that's what includes ETFs. And please let it have it. df dot df where your twin looks similar to you and he likes this trading stuff too. Answer to both of those is definitely not. My twin looks nothing like me. He has a big, huge, giant beard, and I have kind of a round face. I have a big, huge, giant head. He has a narrow head. He's skinny. I'm wide. What else is different about us? He's not interested in any of this technical analysis stuff. He's a strength coach. He does weightlifting for a profession. So we want df where df dot account symbol is equal to me. Damn it. Alright, so let's look. I need a data source which gives results for the volatility index. I want the open, high, low, and close of the index for each day. The data set needs to be updated daily. It also needs to be free. Give me available It also needs to be free. It also needs to be easy to automate retrieval of the data. No, like his body type is skinny. He's what do you call it? It's like endomorph, ectomorph, mesomorph. So I am endomorph or ectomorph. I think ectomorph is the skinny one. Ectomorph versus endomorph. Yeah, this is the image they show. Yeah, my brother's an ectomorph. I'm an endomorph. He has narrow shoulders. I have wide shoulders. It also needs to be easy to automate retrieval of the data each day. Provide me with options which satisfy these requirements. What do you mean? You don't think I'm an endomorph? Maybe I'm a mesomorph, but I can tell you for sure I'm not an ectomorph. Here's the exact Python implementation of the algorithm from Kuhn and Johnson. Endomorph, that's the place to be. My brother inherited my dad's phenotype, which is I'm not sure exactly what it is, but my dad's whole family, they inherit my grandma. I guess it's Irish, and you wouldn't think the Irish would really be endomorphs or ectomorphs. Or maybe they are because the Irish were starved for 1,000 years. They were conquered. The Irish have been conquered from. When did the Vikings invade Ireland? It was like 1070. And to this day, part of Northern Ireland is English. So they've been conquered for the last 1,000 years. And they've been starving for that time. So maybe that's why they're ectomorphs. But yeah, that's what my brother has. He has the phenotype of my dad. My dad's whole family is, his brothers and sisters inherited their mom's physical traits, which is narrow, long face. I inherited my mom's family's traits, which is Scottish bog person. Oh, okay, what are the options? Okay, so I could just pull the VIX data. Well, yeah, but you know, potatoes come from the New World, so that's what everyone always says. The Irish eat a lot of potatoes, but they've only been eating potatoes since, you know, the Europeans made it to the Americas. So 1500. I guess that's kind of a while, isn't it? So let's just see if we could get it from the NASDAQ. Because if I could just pull the CSV from NASDAQ. Oh, good. So we could download the volatility index. Be another one. Okay, then let's put this into our data folder. Prices have more than doubled now. Iran war has interrupted LPG. What's LPG? LPG. Do you mean LNG? The Iran war is something I'm totally interested in. Let's talk about it in the Discord, because I'm trying to get people to talk about that in the Discord, and nobody. What did I talk about? Oh, I said I was interested in Israel's Iron Beam system, I guess, in that post. But I did mention, I said, speaking of the Iran US Israel war, don't look now, but oil has jumped 17% since Friday evening. Watch out for a wild week in the markets. Well, it wasn't that wild of a week, but everything went down basically the whole week. Also, Bitcoin has been relatively flat. That's interesting to me. Look at Bitcoin. I guess it dropped today, but Bitcoin's been pretty high. So look at Bitcoin over the last 5 days. It's up. Look at the S&P 500 over the last 5 days. It's getting crushed, although it did go up for a bit. But, you know, that was just like kind of a rally from the drop previously. So S&P 500 down 1%. Bitcoin up 3%. But if you know about the Bitcoin cycles, if you look at where we're at in the Bitcoin cycle, Bitcoin's supposed to drop all year this year until the end of the year. If it follows the 4-year cycle, it's followed since 2013. So going back 13 years, it's followed the same cycle. So this is very interesting. And you know, the whole case for Bitcoin is that it's money that governments can't manipulate. No, that's exactly right. Anyone who says Bitcoin is gold is stupid. Bitcoin's been around since 2008. Gold's been around since the beginning of civilization as currency. So, that's stupid. Look at this. This is trouble, man. The volatility was low and then it rose, and then look at look at 2008. Rise in volatility. This looks just like the current rise in volatility right before the mega market crash. And then what was 2000? I guess it didn't get too crazy here. Anyway, I think this is the Asian market crashes right here. Okay, so now we have this data. We want to put it in new tab. Let's put it into data. And let's change it from a CSV. So look how big this is. As a CSV, it's 160 kilobytes. Who cares? We'll just leave it. Okay, so okay, how did this perform? Oh, here it is. Hello? Hello? Oh. Raised up, placed, new. Alright, so I want to be consistent, so I forgot. Whoa, 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 whoa. Oh, I just gotta exit out of this and it'll evaluate. So it looks. The staircase stuff, at least this is more consistent at the bottom. Middle's still kind of confused. Top is kind of consistent. How did the cumulative beta do? So here it got up above 50. That's not clearly better. Hello? Hello? Vesta blesta, numa ye. Numa ye. Numa ye. Okay, I saw regime feature last. Oh, I exited out of it. But we'll just run it again. But yeah, I don't know. I've run several models, but I did see the regime feature at the top earlier, but I'm not sure what model that was. Damn, I didn't put it in anywhere. Alright, we'll see what's at the top. I'm running it again. Ugh, I inhaled some beer. Numaye. Kragostadinle. Alright, so how did it do? Did it do better? I don't care about directional accuracy. IC 0.0235. Oh, okay. IC improved. Standard deviation IC got worse. It increased. Okay. ICIR got worse. IC annualized got worse. T-score got worse. So all of my metrics got worse. I expected the metrics to improve. Boom, boom, I want you in my room. Boom, 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 I want you in my room. Well, Fred is an incredible, free, automatable resource. Do not use Fred for the specific task. Fred only publishes daily close. Oh, well, I don't know. Daily close will be fine. Oh, good. It tells a specific story. Okay, I gotta go to the bathroom again really quick. I'll be right back. All right, all right, all right. Okay, so, okay, yeah. So it's saying, I'm saying these are my problem. Everything went up except IC. What do I make of this? IC up. Raw predictive edge actually improved. By stripping out the redundant noise, the model was forced to focus on the cleanest, strongest signals. On an average day, its predictions are now slightly more accurate. The day-to-day volatility of your model's performance spiked. It is now having... Yes, look. The 200-day regime metric. So whatever the regime is over the last 200 days is the top metric. Oh, look, and the second best metric is the 60-day regime. I mean, that seems pretty good, right? It's like long-term regime is most important. Medium-term regime is second most important. Oh, yeah, and then look, moving average crossover... the 20-day moving average crossover is the third most. So it's all regime stuff. Regime 200 days, regime 60 days, moving average crossover 20 days, moving average crossover 200 days. I like this. And then Bollinger Bands, MACD, then moving average crossover 60 days, then regime 20 days. That's pretty good, right? Also, I wanted to ask you, would you like to play corresponding chess? What does that mean? Correspondence chess AI WCF server? I do love chess. I did some live streams trying to get my chess score up. I'm not that good though. On chess.com, I'm not that good. Yeah. I love chess. I'd be down to play some chess, but I don't know what that means. Correspondence chess AI WCF server. Okay, mean IC up. Okay, it's more accurate. Standard deviation up. It's now having wildly brilliant days, but also terrible days. Because these metrics are ratios, the massive increase in day-to-day volatility punishes the scores. The model is less consistent, so its risk-adjusted performance. So isn't that worse? We would rather trade the predictive edge. Or do we only care about the predictive edge? My intuition is that you would rather trade some predictive edge for more stability. You make like 10 moves in 50 days. No. Oh no, I hate that kind of chess. I get bored. And then, because each one you have to analyze like so much in depth. You have to do a ruthless analysis. And then I get lazy, to be honest. I'm a pretty lazy chess player. I like to play blitz chess. I like to play 3-minute chess. Why did this happen? In your tune params function, you're tuning a parameter called feature fraction between 0.5 and 1. This tells LightGBM to randomly drop a percentage of your features every time it builds a new tree. Before feature reduction, imagine you had 5 highly correlated momentum features. Because of feature fraction, and LightGBM might drop it, but it still had MACD. This is created. Oh, so if I had more features while it's dropping out features, it's more stable. After I deleted everything that's, what's that called? Correlated. Well, add me on chess.com. I'm PGL3. All lowercase. PGL3. And yeah, we should play some chess. I love chess. I'm lazy. You're not lazy like me when it comes to chess. At the end of the day, I always think I want to improve at chess and get really good. But then I always feel like, what is the point of this? What is the point of getting really good at chess? I could play chess. That's basically all I care about. I could beat people who suck. That's it. My all-time best rating on chess.com was like 1150 before the pandemic. And then it fell off. Now I'm like 700. I don't even know if I'm 700. I might be 600. Or, heaven forbid, even lower. Doesn't mean feature reduction's bad. Since you fundamentally changed the structural shape of your data set, your previous LightGBM. Okay, so that's one thing. Check your reduction threshold. Okay, so the two things. Where'd the PowerPoint go? Who knew heaven was a place on earth? Does forbidding LGBM from dropping features improve performance? Do you know what that's worth? Who knew heaven was a place on earth? All right, so we have 6 concurrent viewers. So I'll take this opportunity to say, please subscribe. Go to the GitHub, star it, watch it, fork it, follow me on GitHub. Go to the Discord and let's get some interesting conversations going. The GitHub stuff really helps me out, raise my coding profile. So I would appreciate it if you did that. And subscribing, that helps me out too. So please do all that stuff. The links are in the description. All right, so that's does forbidding it from dropping features improve performance on Model 12? And the next question is, does increasing the reduction threshold improve performance? Okay, so I'm going to forbid it from dropping features. Feature fraction is 1. So include all the features. Model 12, all features. Model 13, features trimmed. And, okay, then we have Model 13. Dropping forbidden. What's up with this? Is it stuck? Or is it dropping the features? Did you ask Gemini how to parse out the different regimes identified through the feature? No, I forgot. Honestly, the feature was a while ago. I forgot what it was. How's it defined? Let's just go see. What was it? To parse out the different regimes? You mean parse out the different regimes, like how to interpret it, what the feature's doing? Oh yeah, so regime is ADX regime. Oh, so this just gives whether it's strongly trending or not. But it's not getting if it's returning up or down. But, so this isn't involved in one metric, but I do have the moving average crossover, which should give if it's trending up or down. Metrics for determining regime in the stock market. So yeah, the ADX is basically a volatility regime. I have Hurst exponent. I don't know. Honestly, my brain is cooked right now. I want to see what this outputs. So the If I stop it from dropping features, then the moving average crossover becomes more important than the regime. Okay. Beta's lower. So does this outperform it? So robust rank IC 0.0235. What the fuck? So this makes it worse. Standard deviation is worse than this, but better. No, worse. ICIR is worse. T statistic is worse. Okay, so this makes everything worse. What's the argument I can add to this? So we'll say threshold. Save this. What was the thing I was looking at? Regimes. Let me just put a note in here. So I could put this stuff in. So model 13 threshold equals 0.75. This guy will say threshold equals 0.9. Okay, let me add this stuff to the GitHub. Oh, that's saved in here. All right. So let's push the origin. Ugh. Okay, so it's tuning. Oh yeah, so now I want to add a note. Wait, what's funny? I forgot what it was. Alright. I want to see how this does. Come on, thing. Trial 21. You're making an account for what? Chess.com? Yeah, what else could we look at right now? Just, all I could say is, write things in the Discord about stuff you think is interesting. I want to talk about stuff. But people seem to not reply to it. This guy Einstein said, anyone up? Hi, Einstein, I'm up. When do you think the Strait of Hormuz will open? Anytime soon? Nice, yeah. Add me as a friend on chess.com. Are you good at chess? What's your rating? You play long chess, so maybe I'll have an advantage when it comes to blitz. But it sounds like you're more of a chess guy than me. You know all these chess things. Alright, 46. Here we go. 47. 48. 49. 50. Running through my head, running through my head, running through my head. All the things she said, all the things she said, running through my head, running through my head. This is not enough. Even worse, man. Not enough. All the things she said, running through my head, running through my head, running through my head. All the things she said, all the things she said, running through my head, running through my head. Send to back. Alright. I see 0.019. Oh man, this is the worst so far. Robust IC. Alright, so next I'm gonna say okay, so that's my next to do for the next stream. But that's it for now. I'm cooked. It is 1:20 in the morning where I am. So thanks for watching. Have a good rest of your night. Don't forget to subscribe. Join the Discord. Start the GitHub. Download the GitHub. Follow me on GitHub. And thanks for watching. Have a good rest of your night. Adios. Is not enough. be another one. One